Force or pressure problems. Procedure to solve force or pressure problems. Number 1. Draw a y-axis in the face of the dam in the vertical direction and choose a convenient origin. Often take the base of the dam. 2. Find the width function or W of y for each value of y on the face of the dam. Number 3. If the base of the dam is at y equals 0 and the top of the dam is at y equals a, then the total force on the dam is F equals m times a, or the mass times acceleration. From the density rho equals m over v. Therefore, the m equals rho times v. And the volume is the area multiplied by the thickness. And the area is the width times the depth. So the total force on the dam is F equals the integral from 0 to a, or the bottom of the dam to the top of the dam, of rho times g times a minus y as the depth, w of y, which is the width, this represents the area, times the thickness, which is dy. So the depth is measured from the top of the dam to the current position. Let's look at the example. Parabolic dam. The lower edge of a dam is defined by a parabola y equals x squared over 16. Use a coordinate system with y equals 0 at the bottom of the dam to determine the total force on the dam. Lengths are measured in meters. Assume the water level is at the top of the dam. Given that the rho, which is the density of the water, is 1,000 kilograms per cubic meter, and the G is 9.8 meter per second squared. The parabola y equals x squared over 16, and as the y-axis going across the middle of the dam, make it symmetry. At the level water y, we look at one layer, and y is between 0 and 25 as the coordinate 20, 25. So the y is 25. So the thickness is dy. The width, which is the measurement across the dam, this measure as x, this another x. Therefore, the width is 2 times x. As the function y equals x squared over 16 represents the lower edge of the dam. Therefore, x equals 16 times y to the and raised to the power 1/2, or square root of 16 times y, which is 4 times square root y. That means the width is 2 times 4 square root y, or 8 times square root y. The depth which is measured from the top of the dam, which is 25, to the current position, which is y. The total force is the integral from 0 to 25, the rho times g times the width times depth times thickness. Rho and G are constant, which is 1000 multiplied by 9.8. We take it out of the integral, which is from 0 to 25. And the width is 8 times square root y. The depth is 25 minus y. The thickness is dy. And simplify the integrand. And we can also bring it outside of the integral. So 1000 times 9.8 times 8 gives us 78400. Integral from 0 to 25. Square root y means y to the power 1/2. Y to the power 1/2 times 25. 25 y to the 1/2 minus y to the 1/2 times y, which is y to the power 3/2 with respect to y. And then find the antiderivative. 78,400. Antiderivative of 25 y to the power 1/2 would be 25 y to the power 3/2 multiplied by 2/3 minus y to the power 5/2 divided by 5/2 or multiplied by 2/5. Evaluate from 0 to 25. The first term becomes 50/3 y to the power 3/2. Substitute the upper limit. 50/3, 25 to the power 3/2 minus 2/5, 25 to the power 5/2. And then subtracted by substituting by the lower limit, which gives us 0. And simplify the number to be 65333.33. Repeating. The unit is in Newton.